Welcome to all. This is part 2 of title. You can see analysis of single A in post, WA in post and T section. Remember, still we are not gone to particular part. We are discussing general concept. Means what all we are considering now is common for all three: single A in post, rectangular, or WA in post, rectangular, or T sections. After completing, I will tell you. Now we will deviate for respective part. Okay, start now. Now I will discuss about balance section, under in post section, over in post section. You can see a star mark here. See, 2 star marks are there. I written here. What is that star marked for under in post section? I will discuss it later. Remember, very powerful concept. If you want to understand limit state method, if you do not know what explanation I am going to give for star, if that is not known to you, then you don't have any basic knowledge of RCC, analysis for flexion of RCC by limit state method. Okay, start. 1 minute. Later I will come to it. Now, we want strain diagram. See, if the bending is sagging, top compression, strain diagram will come this way. Epsilon C, epsilon ST, compression tension. This is your neutral axis XU. This is if sagging BM, top compression. If hogging BM, diagram will come. This is epsilon ST. This is your epsilon C. This is compression. This is your XU. For this purpose, we cannot write 2 times. What all statement I give here, turn it. Put it, this one, you write this side, this one that side, mark XU from this side, it will become for hogging BM. So that is not required. I already told so many times that one. So now, for further discussion, what I will do is, one concept, I will take sagging BM. So because something required, okay. So top compression, bottom tension, extreme compression edge. This I am telling always, I won't write now. This is the extreme compression edge. The full depth is D, remember, everywhere here, full depth is D. See, there are 3 diagrams here, all are projected here. Okay, now, first come to balance section. Definition of balance section, I already told last time, I wrote in the board. So I will dictate once briefly. A balance section is one in which area of tension steel provided is such that when the maximum compressive strain in concrete reaches 0.0035, simultaneously strain in tension steel will reach Fy by 1.15 ES plus 0.002 sufficient. Last time written on the board. Now for a balance section, see, green color is XU. Red color is for balance section, for understanding. Balance section, your XU is equal to XU max. I already told it. Compression tension, neutral, red color is neutral axis for a balance section. Okay, now. So when epsilon C reaches 0.0035, simultaneously means at the same time epsilon ST reaches Fy by 1.15 ES plus 0.002. And for a balance section, our XU is called XU max. Or XU by D is XU max by D. That is not required now. You remember one of them. Divide both sides by D. Now, proceed. See, consider beam with the same depth only. Project here. Remember, this class I told I will tell you procedure to find ultimate MR. These all are not in the scope of this course. These all I explain thoroughly in the regular course. But still, I thought little understanding so that let people get benefited. Therefore, there is a limitation. Suppose someone will ask more and more details, I will tell sorry, that is in the course only. At least some minimum requirement I am telling. Come to under reinforced section. See, definition I will dictate for you. Over reinforced section, definition I will dictate. But actually, it is same definition as working stress method. Balance section definition is different. Working stress method, balance section, you define how? When the maximum stress in concrete, in bending, reaches permissible limit of sigma CBC, at the same time, stress in tension steel reaches sigma ST. Then X equal to XC there. Okay, now, There stress language, here strain language. Okay, now this under reinforced section. Those who want, write here. Simple one-liner. Under reinforced section is one in which area of tension reinforcement provided is less than that required for a balanced section. Okay, right here. Then little later, when the time comes for over reinforced section, you write at that time. Over reinforced section is one in which area of tension reinforcement provided is more than that required for a balanced section. Okay, now under reinforced section, what will happen is, see, amount of tension steel provided, area of tension steel provided, for that matter cross-sectional area of tension steel provided is less than that required for a balanced section. Therefore, strain in tension steel will rapidly increase. There, see what all I told in working stress method, same here. There stress I told, here strain. So finally a stage will come when strain in tension steel will reach Fy by 1.15 ES plus 0.002. At that time, under reinforced, strain in concrete will be less than 0.0035. So therefore, see here, if this is 0.0035, if this is that number, this will be equal to this much only. But this will become lesser when you join, yet neutral axis will shift upwards. See, green color is neutral axis for the particular section. So your XU is less than XU max, or common sense. From the see, when the neutral axis for balanced section, when you reduce the area, CG will shift to other side. Okay. Now, therefore, when epsilon ST reaches for a balanced section, what happens? When strain in tension steel reaches Fy by 1.15 ES plus 0.002, at that time, strain in concrete will be less than 0.0035. This is for under reinforced section, XU less than XU max. Now, remember, under reinforced section will have, you should write here, under reinforced section is having primary tension failure. Right? Actually, what happened is, no problem. I thought I am writing other one. Okay. I can make out now, see. Primary tension failure. Now, primary tension failure, you can write, it is somewhat ductile failure. You can make a note. You should write here. Some people refer it as ductile failure, which is gradual and with sufficient warning. It will not fail suddenly. Gradual, slowly, and with sufficient warning. Furthermore discussion will come in star. It will come in the star. Okay, time being, leave it now. Over reinforced section. You are providing more steel than balanced section on tension side. So strain in concrete will rapidly increase. So finally a stage will come when strain in concrete will reach the maximum limit of 0.0035. See here, this is equal to this much. But at that, or you can do one thing, just to understand, I will do one thing. See, just to understand. See. Okay. The strain in concrete will reach 0.0035. At that time, strain in tension steel will be less than Fy by 1.15 ES plus 0.002. Therefore, see, this one, this will become lesser, join, this is your XU. So your XU will be, where I wrote, more than XU max. Actually, you can write, here only I write once again, this XU is what? Less than XU max, you can write here. See, this red color is XU max. This XU is more than XU max. Okay. Or when you provide more steel, centroid will shift towards that side. Now, here, for over reinforced section, when strain in concrete in compression, extreme fiber strain, maximum strain, reaches 0.0035, strain in steel will be less than Fy by 1.15 ES plus 0.002. Written here. So, actually I don't know. Actually what happened is, I wrote over reinforced here. See, okay. What I first wrote, it's interchange. Therefore, okay. For, actually what happened is, this I added afterwards. When I came here, I first wrote under reinforced here and over reinforced here. Now I can make out. See, such mistake will not happen. Therefore, for over reinforced section, XU is more than XU max. And remember, make a note here. Over reinforced section will have primary compression failure. Some people call it as brittle failure, which is sudden and without any warning. Therefore, not preferred. This is okay. This is a basic part now. So, remember now, I will tell now only, write correctly now, here, not there, don't worry, right here. Whenever we have to perform the analysis for flexure, see, analysis for flexure means bending strength, then for a given cross section, singly reinforced or doubly reinforced or T section, whatever it is, you first find the value of XU, depth of neutral axis for the given section. Then find XU max. What is the depth of neutral axis for a balanced section? Imagination. Compare XU with XU max. If XU comes less than XU max, you write cross section is under reinforced. If XU comes more than XU max, write cross section is over reinforced. Then what to do, I will tell at that time. Okay. Now, very, very important. What is that star marked for under reinforced section? I will discuss that one now. But remember, I won't discuss. I will ask one more question. I will, as I go further, when I remove this one from the board, some argument or some principle I am going to tell. Then I will tell the actual meaning of the star written here and star written here. See, star there and star here. See, where are your star? One star is for this one more star is for this one. Okay. Now, but I will tell you, there is a requirement for it. Right from beginning of when I started uploading classes in YouTube, it is already more than 350 or it is approaching 400 now. I told everybody, write your comment. I should know how is the response, how you feel. Nobody bothers to write a comment. And people are not going to fully, I know it. They see as if it is a video for entertainment. No, this is a serious, it is not a video, it is a serious class for understanding. Therefore, I will next, when I remove this one now, some argument based explanation I am going to give now in the board. Then I will start the analysis. This actually class number 2 is some logical class. Now, understanding the meaning of star, or what I am, if I tell, what I will tell for the star mark is very, very important for limit state method. If that is not clear, I will tell you do not know anything about limit state method for bending. For bending, usually bending only comes everywhere. Now, condition. I will wait for some time. I will not tell right now. See, when I go to procedure, it is not required. I will tell the procedure. When I tell procedure, I will tell what I tell you, do it. It is correct. Wrong procedure I will never give. So, you proceed further. That is for those who want to only solve the problem, not to gain knowledge. So, in the comment box, when I receive request for explanation of star, at least by 100 members, 100 unknown people, very important. There are so many people who come to my classes, regular classes. So they will keep on writing, yes sir, please explain that one. No, they are not considered. When I get 100 requests for explanation, remember it is worth. Suppose you go outside, I will tell you with regret, 99% people, those who know how to solve limit state method problem solve, I am not in teaching staff, general civil engineers, 99% will not be knowing that concept. It's a very delicate concept. Or in the comment box, if you want, you can write the answer. Welcome. In the comment box, see, whatever way you give the answer, I can give it much, much better than way. Suppose you give the answer in just 3-4 lines. I will talk for 3-4 hours then, no problem. So that is secondary. So either you comment there, what reason you think, you comment there, or put a request for that explanation is required. When I receive 100 requests, I want that come from you. See, when a small kid is hungry, the kid will weep, then only food will be given. I need not keep on telling everything, whether people see it or not, or go through it or not. Why should I give? See, it is a very delicate concept. So I want proper response. When I reach at least 100 requests for that one, suddenly I will write class for the concept. That star, I will title, I write explanation for the star for under-reinforced section. Then full I will tell. Okay, now I will remove this one now. I will go to next part. That is a little more about star with a question for you, and little further about resultant compression force, resultant tension force, and moment of resistance. I will explain that one. We'll continue. Little more information. Remember, this all I am giving because systematic way derivation in the class will not be done. Equations I will be giving. As I told in this course, it is only how to analyze. Too much theory will not be there. Still, for benefit of those who are serious, in limit state method, to locate neutral axis, that is to find XU, depth of neutral axis for the given section, that is actual depth of neutral axis, equate Cu to Tu. Cu is resultant compression force. It need not be in concrete. If WA in post section is there, it will be in concrete plus in ASC. So we simply call resultant compression force. Tu is tension force. That is force in tension steel. Now make a note. Whether it is single A in post section, or WA in post section, or T section, in all three cases, concrete in tension zone is ignored. Tension is considered to be resisted only by tension steel. Therefore, see, this will keep on changing. For single A in post, Cu, WA in post, Cu, T beam, Cu, it will keep on changing. But everywhere, your Tu will be same. It is always equal to 0.87 FYAST. Like working stress method. When you locate neutral axis, LHS will change for single and doubly, but RHS is same, MAST into D minus X. Okay, now, note, in general, force due to stress equal to stress into area, cross-sectional area. Whenever you want to see, you require force here. Whenever you want force, it is stress into area. But remember, force equal to stress into area only if stress is uniform. So that you use it for steel. So when you want to find force in steel, you consider equal to stress in steel into area of steel. Of course, along the diameter, there is slight change in the stress. That is ignored. No variation. So that variation along diameter is not considered. So whenever you want, I will not tell once again later, because this is the extra I am telling you. Whenever you want force in steel, you simply multiply stress in steel into area of steel, but cross-section area of steel. For AST or ASC both. But for concrete, compressive stress is varying. See, you know it. It comes this way and this way, all you know it. So it is not constant. When the stress is varying, this I told in working stress method, then you have to consider average stress. So whenever compressive force in concrete is required, then compressive force in concrete equal to average compressive stress in concrete into cross-sectional area of concrete in compression. So for steel, directly stress into area. For concrete, average stress into cross-sectional area of concrete in compression. Now, where this force will pass through line of action? If it is steel, directly through CG of the steel. Okay, but if it is concrete, when stress is varying, line of action of this force will be through centroid of the compressive stress diagram for concrete. You know it, 0.42 XU. Diagram considered. Okay. Now, last concept. Very, very important. When we find ultimate MR, this I will tell you later, ultimate MR. That is MU. Then MU equal to CU into A or TU into A. Reason. CU equal to TU, it will form a couple. That moment of that couple will resist the, or it will resist the external bending moment, MU. This all I told in working stress method. Limit state method, working stress also, for you formula given. In the regular class I told. Limit state also I told in the regular batch. Regular batch, to cover this one, I took 2 classes, that is around 3 hours. But here, MU equal to CU into A or TU into A. Now, very important, very, very important. See, actually, very, very important comes here. You can do one thing. That very, very important is not there. It is here. Here and here. Here. Now, very, very important is the MU equal to CU into A or TU into A. Okay, now, for under reinforced section, we can consider any one of them. You can consider MU equal to CU into A or TU into A. Whatever you want, you can consider. Both will give same answer. Remember, only for under reinforced section, we can consider MU equal to, if you want, you can consider CU into A or TU into A. Both are same, no problem. But for over reinforced section, danger. For over reinforced section, directly use MU equal to only CU into A. Do not use MU equal to TU into A. That does not mean that you cannot use TU into A. Of course, it can be used, but with corrections. With corrections. So, it requires what? If you use MU equal to TU into A, it requires additional calculations. Additional calculations. Therefore, better avoid. Better avoid. Therefore, I will tell once again here, you write a block here. Big block you write here. Under reinforced, write a big block. You should write. Under reinforced section, that is XU less than XU max. You can find ultimate MR either by CU into A or by TU into A. Any one of them will do. No problem. But over reinforced section, do not use TU into A because it will give wrong answer. Of course, it can be used, but with the corrections or some modifications are required. So, lastly I will tell, under reinforced section is always welcome. Remember, welcome. So, because why? Slow and gradual or with the warning failure. So, under reinforced section, you are fully free. You can use MU expression either based on compression or based on tension. But over reinforced section, see, do not use based on tension. Over reinforced, too much steel is there. Do not use that one. For over reinforced section, use MU equal to CU into A only. Use this one. Here, what? Use any one. Either this one or this one. Okay, done. Now, come to the star. I told, I will take one class for around, it will be around 1 hour. Beautiful concept. Actually, that is where you will understand what is limit state method. I told 99% they are not knowing. I am so sure. If you go to working stress method, if you remember, if section is under reinforced, then FCBC permissible is less than sigma CBC, but FST permissible is sigma ST. Means under reinforced section, what? Stress in tension steel will reach its permissible limit. Stress in concrete will not reach permissible limit. Therefore, for under reinforced section, we cannot use full strength of concrete. I will tell that way. We cannot use full strength of concrete. In the stress language, that is sigma CBC. If you remember, you have to find permissible stress in concrete. Suppose, imagine M20 concrete or M25 concrete. Okay. Sigma CBC is 8.5 Newton per mm square. If it is under reinforced section, stress in steel will reach the critical. It depends upon which steel. Then stress developed in concrete will be less than this value. Even though its strength is 8.5, you have to consider lesser. See that? Once again, go to working stress method. You maybe say permissible stress in concrete. In concrete, I told is less than sigma CBC. Say some number, 7.8 Newton per mm square. So even though concrete got a capacity of 8.5 Newton per mm square, we cannot use the strength. You have to limit the stress in concrete to 7.8. Working stress method. But sorry, it is a Kannada word, usual habit. But people who are not my Kannada, excuse me. But in Kannada, but means adare. Okay. Sometimes suddenly comes mother tongue word. But in limit state method, see now, I wrote, you can find mu equal to cu into a or tu into a. Now, very important. In case you use cu into a, where to write it now? Okay, in case, here now, see, in limit state method, if we use for under reinforced section, mu equal to cu into a, then we are considering full strain in concrete. Epsilon C equal to 0.0035. We are considering epsilon C 0.0035. But just now I wrote previous side, see there, little earlier I wrote here, if it is under reinforced section, strain in steel will reach Fy by 1.15 ESC. Just now I told, little earlier, that under reinforced section I told, strain in steel, epsilon St equal to Fy by 1.15 ES plus 0.002, whereas at that time, strain in concrete will be less than 0.0035. So, as per a definition, strain in concrete will not reach, when the strain in steel reaches this value, strain in concrete in compression will not reach 0.003, like working stress method. When stress in steel reaches sigma St, stress in concrete will not reach sigma CBC. So, we cannot use the full strength. So, here also, actually, you cannot use it. See, we cannot, right here, we cannot use, still we can use. This is the beauty of limit state method. Full contradictory statement. Concrete strain, when the steel strain reaches that value, strain in concrete will be less than 0.0035. It will not reach 0.0035. So we cannot use it. Even if you cannot use it, we can use it. That is the enjoyment of star. That's why the star is the most powerful for limit state method. So, comment. Request means not like this request, not that way. Request, I should not tell, I can't tell you order. You can't order me. So, student can always request, no problem. So, let at least minimum 100 requests should come to me in the comment box that explanation is required. And one more thing, from unknown people, the moment they comment, I can see known people, I know the people who are coming to my regular students, I know. So that is not considered. They always tell me want it. No. General public, at least if 100 comments are there, I will take 1 hour class meant only for that beautiful concept of limit state method. Okay, done. Now, let me see how much is the space there. Okay, I can continue a little more. See, I have not even cleaned the board neatly because this is not my responsibility. Because when I told what course I am conducting now for in YouTube is for general public procedure to find ultimate MR for single A input, W input and T section. So I should give formula and tell. All this I told, I need not tell. But still for those who are interested, I will not prepare. I will write in front of you only. See. Now, only for information, remember. I won't use color solve. I use only, okay. Only for information. Only for information. You can see how I write now. Sagging BMU consider. So that only one explanation. Rectangular section. See, first I will tell now, I won't waste time. See, first of all, it is not my responsibility. This is AST. I won't use color. AST, this is the neutral axis. This distance is XU. This from here to here is effective depth D because this is extreme compression edge. I am first telling now singly reinforced rectangular section. I am telling now only for understanding purpose. Next class, very slowly I will give equations. Full systematic. Okay, now see, stress diagram. Right here, compressive stress diagram for concrete. This is 0.45 FCK. Center of gravity is here. This is CG. This distance is 0.42 XU. And for the full stress block, average stress, this all I told you, equal to 0.36 FCK. Okay. Now, through CG of the compressive stress block, this is the area resisting compression. This is area tension. With a resultant force Cu here, which will act at 0.42 XU because you know center of gravity is at 0.42 XU. Tension force will pass through line of action of tension. Line of action of tension force Tu will be through CG of the steel. This is called lever arm. So lever arm equal to, this is D. Remember, I am not taking a systematic class now, just giving information for those who are interested. Okay, now, first, Cu, resultant compression force. Area, average stress. I told, stress is varying. So, formula is what? Average stress into area. Average stress into area for compression equal to average stress. 0.36 FCK is the average stress into area in cross section is B into XU. B into XU. Therefore, your Cu will become 0.36 FCK into B into XU. Okay. 1 over. Same way. Tu. Stress into area. Just stress in steel, tension steel into cross section area for tension steel. Stress in steel, I told you 0.87 Fy into area of steel is AST. This I told you, design stress in steel. Oh, I think I told or not. If not told, I will tell you next time. Okay, today actually Fy is right here. Fy is the yield stress, partial safety factor of 1.15. It is Fy by 1.15 or 0.87. Okay, Fy. Remember. So your Tu will come 0.87 Fy into AST. Now, for locating neutral axis, equate Cu to Tu. Therefore, we get, I will put in the green color to understand, we get 0.36 FCK into B into XU equal to 0.87 Fy into AST. Equation for, right here, equation for locating neutral axis for a singly reinforced rectangular section. Okay, next. Mu equal to Cu into A or Tu into A. Start. Consider Mu equal to Cu into A. You already know A equal to here. It will become Cu. 0.36 FCK into B into XU into A is D minus 0.42 XU. Therefore, remember the basic equation is Mu equal to 0.36 FCK into B into XU into D minus 0.42 XU is the basic equation. Mu basic in terms of what? In terms of compression. I told basic. And now, and also, make a note here. We will go to IS code version. What IS code has done is, they simplified it equal to 0.36 FCK into B into XU. They divide by D and multiplied by D. From here, they have taken D outside. 1 minus 0.42 XU by D. Therefore, same basic, this is same basic equation, same in IS code is, Mu equal to, see first this one, 0.36, next this one, XU by D into bracket 1 minus 0.42 XU by D into B into D square into FCK. This is the same equation, IS code version. These two are Mu based on Cu into A. Okay, now I will write here other Mu. Over, today's class over. See, now I write here. Okay. Consider, I am writing very fast because this is not my liability. I am only giving extra information. This much speed I never take the class. Mu equal to Tu into A. Then Mu becomes Tu is 0.87 Fy into AST. Therefore, Mu equal to into D minus 0.42 XU. This is the basic equation. This is the basic equation. Now, IS code version. What they have done is, they put once again equal to IS code. 0.87 Fy into AST. They took D outside here. D into 1 minus 0.42 XU by D. Now what they have done is, XU by D is here. See, use the equation here. Now, they replaced, now see, we got, see, wait 1 minute now. We have 0.36 FCK into B into XU equal to 0.87 Fy into AST. See, from here you can tell XU equal to 0.87 Fy into AST divided by 0.36 FCKB. Now IS code divided by D here, divided by D here, this XU by D, they substituted here. Then I will remove that one now, because why? This is only for information. Too much neatness is not required for this one. Too much neatness, etc., nothing required, just for information. Okay. Then, sorry, if I used a little wet watermark will be there. I should add it. Okay. Those who want, write seriously. Okay. Then, still I have to wait for some time. Okay, I rub this diagram. I will rub it with the other one here. This one I will remove. Right here. Then your Mu becomes 0.36 FCK, where is this one? 0.87 Fy into AST from here, see, into d out d into 1 minus 0.87 Fy into AST divided by 0.36, 1 minus 0.42, 1 minus 0.42 into 0.87 Fy into AST divided by 0.36 FCK BD. Now, see, 0.42 into 0.87 by 0.36 comes to 1.015, which IS code rounded to 1. They told 1, it comes to 1.015. They told, okay, take 1. Okay, so therefore, compared to the basic and IS code version, slight difference will be there. Therefore, IS code version is mu equal to 0.87 Fy into AST into D into 1 minus, see, these three numbers together is 1. AST Fy, they interchange. AST Fy divided by BD FCK. This is IS code version. These two are mu based on mu equal to Tu into A. Okay, that's all. First of all, remember extra information. Someone will tell, he was telling correctly all these days. Suddenly what happened? I just wanted for those who are interested. Others, wait for next time. See, next time, how systematically I will give procedure. And I will see, next time I will tell, equate XU to XU max. That way I will talk next time. It's only for information. So remember, when the number of requests reach 100, I will explain that beautiful concept. Thank you.